The ZotBins hardware and electrical team deploys smart bins in various communities. The purpose is to help educate Americans by collecting useful data and implementing holistic changes for our waste system. We use a suite of sensors to collect waste data for facilities management, manufacturers, and bin users as a tool for improving our waste system. To collect real-time bin fullness data, we use a HCSR04, an ultrasonic module. It transmits ultrasonic waves and calculates the time for those waves to bounce back and calculates the distance. The HCSR04 is placed at the top of the bin and sends the ultrasonic waves downward towards the trash or the bottom of the bin. The waves bounce back to the sensor, and the time elapsed is used to measure the distance from the top of the bin to the trash. As the bin fills up, the distance measured decreases, and once it reaches a certain threshold, it means the trash needs to be taken out. To detect how often people use the waste bins, we use a brake beam sensor. This module transmits infrared light to a receiver unit. As soon as the infrared light beam is broken, it records the response. The light beam is broken whenever someone throws trash into the ZotBin, thereby sending a signal to the Raspberry Pi. To see how much waste is accumulated, we use a load cell. The load cell is connected as a Wheatstone bridge with a HX711 amplifier. We then perform some calculations to determine the weight of the trash. To collect images for our waste recognition team, we use a Raspberry Pi camera V2. It collects images every time something's thrown away. When the brake beam sensor detects trash being thrown away, it sends the information to the Raspberry Pi, which then prompts the Pi camera to take a picture of the trash. To make all the sensors work together, we use circuit analysis and create an optimal circuit so that our microcontroller can communicate and activate the sensors. The Raspberry Pi microcontroller is used as a platform to add any sensors easily. This is an extremely powerful microcontroller that controls all the sensors on the bin and makes it very easy for us to add another sensor. We can add more sensors as we deem necessary for the data we want to collect. In order to do so, we simply connect the sensor to our microcontroller, which is the Raspberry Pi, as we have done with the other sensors. After our initial circuit prototype, we designed a custom PCB for large-scale manufacturing. This makes everything neater, cleaner, and sexier. It's also more compact. Finally, we put it all together and assemble our smart bins.